Majestic in their simplicity, awe-inspiring in their size, they've housed every imaginable flight vehicle created. Now, Hangars on Modern Marvels. Shelter, refuge, sanctuary. We seek these comforts to fight another day. For more than a century, hangars, or sheds as they're known in Europe, have provided the same sense of security for all flight vehicles. The larger the aircraft, the larger the hangar. Today, nowhere does that principle resonate more than in Bonn, Germany, about 60 miles south of Berlin, and now home to the largest hangar ever built. Imagine a single edifice large enough to completely enclose the Louisiana Superdome. Cargo Lifter's new mammoth hangar is such a beast.
The cargo lifter shed by Brandt is an absolute humongous structure that overshadows anything that we've seen to date, including anything that was ever built in the United States.
This hangar is roughly 1,200 feet long, 700 feet wide, and 350 feet tall. Without any support walls, it is the largest freestanding building in the world. This hangar will be home to the immense CL-160 airship. The CL will be 853 feet long and nearly 200 feet wide. It will be the biggest airship ever built, more than 50 feet longer than the Hindenburg. Construction began in March 1999 on an empty Russian military airfield. It took nearly 1.5 million cubic feet of concrete just to secure the foundations for the 5 overarching steel girders that make up the hangar's frame. The girders themselves are comprised of 14,000 tons of steel apiece. The only way to secure the 3-layer membrane that stretches between each of the arches was for workers to hang from ropes attached to sections of the frame several hundred feet above the ground. The doors, which resemble a clamshell, slide underneath each other, exposing the hangar to the outside world. They create a 600-foot wide, 300-foot high semicircular opening at each end of the hangar. The structure is large enough to house 14 Boeing 747s, the largest commercial aircraft in the world. Cargo Lifter wants to have 2 airships in its hangar, but have only one in the air at any time. They are risking millions on this colossal structure. They're betting a market exists for heavy cargo transport airships. They plan to carry payloads up to 160 tons and are targeting freight manufacturers, drilling equipment, and heavy machinery companies.
It shows that they're very serious about building airships. A lot of people propose to build airships, but they forget about building the hangar first.
Now that its hangar is finished, Cargo Lifter is moving quickly on plans for its mammoth airship. Filled with helium and powered by helicopter engines, the CL-160 will be so large that a 2-bedroom house could sit comfortably on its tail fin. Cargo Lifter hopes to have airships flying by the end of the decade. These dramatic efforts signal Germany's re-emergence as the industry's leader in size and quality of airships, and the cathedrals that house them.
I would say that we are witnessing a remarkable revival in interest in lighter-than-air. Almost 60,000 individuals have invested in the Cargo Lifter. There are a lot of people willing to take a certain amount of financial risk, if you will, in seeing if it's feasible to build an airship of that size.
All airships, cargo lifters included, have been distinguished by their great size. Accordingly, their dwellings have been just as massive. In the late 1880s, hot air balloons were housed in hangars and used to take passengers on short flights. But German Count Ferdinand von Zeppelin, who rode in a hot air balloon as an observer during the US Civil War, had grander plans. He wanted to build massive lighter-than-air vehicles.
And he said, what would happen if I took a series of round balloons and I put them all together? And that would form an elongated balloon.
Von Zeppelin envisioned putting a frame around his balloons. This would give his craft stability and greater carrying capacity. He would be able to travel greater distances, increasing the chance for his grand plan of commercial passenger service. But before he could build his new airship, the 416-foot-long LZ-1, von Zeppelin needed to build the world's largest airship hangar. The 490-foot-long, 52-foot-wide, and 52-foot-tall hangar was a technological marvel in 1900. The wooden structure was built on water, sparing von Zeppelin the need to buy expensive land. To stabilize the shed's outer shell and floor, workers secured a 41-ton anchor to the bottom of Germany's Lake Constance, about 1/2 mile from the shore. For 6 months, more than 100 men constructed the hangar on the lake, towing wood out to the site.
The hangar itself is built on pontoons, anchored on the one end with no door on that side. On the back side was simply an opening in which a second pontoon, actually it's a pontoon floor, could leave the entire shed with the airship attached to the floor.
Now freed from the hangar, the airship was lofted skyward by the ground crew. The LZ-1, like all airships, had to take off directly into the wind. This gave the ground crew more control of the airship.
And that's what he very cleverly did when he towed this floating hangar out on Lake Constance and was able to launch his airships there.
After completing its mission, the airship would return to the platform, be tied down, and then with the help of tugboats, be pushed back into the hangar. Von Zeppelin quickly moved forward and began building more airships and more hangars. In fact, Germany had erected 22 airship hangars by the start of World War I. But von Zeppelin's double shed in Friedrichshafen, the first in the world, was his crown jewel. It could accommodate 2 airships at the same time. The mammoth facility was a staggering 603 feet long, 150 feet wide, and 82 feet high.
During the wintertime, the airships were usually hung up in a shed so that the structure not only had to take the weight of snow from the winter months, but also had to take the dead weight of an airship, or in this case in Friedrichshafen, 2 airships, hanging from the ceiling.
Despite the success of the double shed in Friedrichshafen, hangars didn't gain wide acceptance until World War I. As the war progressed, airships were used as bombers. And both single and double sheds were built close to the front lines throughout German-occupied territories. However, along with the benefits of having lots of airships close to each other came the pitfalls. One of these was the Germans' use of hydrogen. The highly explosive gas was directly responsible for several accidents that occurred at hangar bases.
The more famous location was a place called Alhorn. Alhorn had 3 sets, that is, in all 6 double shed standing there. The problem with this arrangement was that the hangars at Alhorn were parallel to each other and they were constructed too close to one another.
As one of the airships was being repaired, it caught fire and exploded, causing debris to land on its neighboring shed, which had 2 airships inside.
A chain reaction occurred in which all 4 airship sheds that were sitting next to one another blew up. The Germans lost, in one mishap, 5 airships, all of the more recent designs, so it was the latest in technology, if you will, and 4 of their brand new airship hangars that they had just built. And these were the largest ones that had been built at that time. They were 260 meters in length and 60 meters wide, and I believe 50 meters high.
With the sudden loss of these hangars and the great hydrogen-filled ship's vulnerability in the war, the German military began rethinking its reliance on airships. But this proved to be a moot point. Following its loss in World War I, Germany was forbidden from building airships and their hangars by the Treaty of Versailles. However, the rest of the world desired airships, and following the war, the popularity of airships and hangars grew. Next, America follows Germany's lead and builds the biggest airships and hangars in the world. Von Zeppelin's floating hangar on Lake Constance was one of over 80 hangars Germany was forced to destroy as a result of the Treaty of Versailles. Hangars will return on Modern Marvels. During World War I, Germany's effective use of airships had impressed U.S. military officials. In fact, immediately after the war, the U.S. began searching for places to house and launch their own airships. In May 1919, the U.S. Navy purchased 1,700 acres of land in Lakehurst, New Jersey, with the intent to build America's first airship field. Only 6 months later, ground was broken on what would become Hangar 1, Lakehurst Naval Air Station.
This hangar was going to be very special because not only would it house airships, it would be used for the construction of the Navy's first large rigid airship, the USS Shenandoah.
Hangar 1 was designed much like the German hangars, but on a significantly larger scale. It was built with Germany's hydrogen-filled airship fleet in mind. At this time, helium wasn't used in airships, so engineers were forced to deal with hydrogen's explosive nature. With Germany's Allhorn disaster still fresh in their minds, American designers were determined to build this hangar with an eye towards safety.
Inside hangar number 1, all the wiring, all the piping, everything was encased in gas-tight fittings. The switch rooms, all types of telephone connections, everything was gas-proof, explosion-proof. The sheathing on the outside of the building was originally asbestos to cut down any damage from fire or sparks.
In 1921, 2 years after construction began, the mammoth hangar was completed at a cost of $4 million. At nearly 1,000 feet long, 350 feet wide, and 224 feet high, Hangar 1 was a jaw-dropping creation. But its 4-leaf sliding counterbalanced doors were the most impressive feature of this cathedral. They each weighed 1,350 tons, as much as a World War I U.S. Navy destroyer, and the doors could be opened mechanically or manually using a capstan.
These doors are kind of unique. They roll outward on railroad tracks. It takes about 10 minutes to open and close the doors, and they were so well built that the doors are still openable today.
The only drawback to these sliding horizontal doors was that they projected beyond the sides of the hangar and created disturbances due to crosswinds. Wind is the greatest cause of problems when docking and undocking any airships. Nevertheless, Hangar 1 was the only structure large enough to accommodate the U.S. naval airships. The USS Shenandoah was 680 feet long and 79 feet in diameter. She cruised along at a robust 60 miles per hour. By 1924, she shared Hangar 1 with the USS Los Angeles, a German-built airship given to the U.S. Navy as part of World War I reparations. Now home to the 2 largest airships in the world, the public was awed by Lakehurst.
Well, it was one of the wonders of the world, and although it didn't remain the longest or largest airship hangar for long, it still continued to amaze people. Even into the 1930s and 40s, sailors that were stationed here remark about how they would get off the train, and then there was nothing but this huge, enormous hangar in the middle of this big, empty field, and Hangar 1 dominated the landscape pretty much as it does today.
The U.S. Navy's success in using airships along the East Coast spurred more hangars and airships to be built further west. All that was needed for the hangar was lots of empty land. In January 1929, the Goodyear Company started construction of a hangar in Akron, Ohio, that would house the largest U.S. Navy airships ever built. More than 1,300,000 cubic yards of earth, enough to fill 400 Olympic-sized swimming pools, was moved from former farmland to construct the world's largest airship hangar. 5 sets of railroad tracks totaling 11 miles supported railroad derricks used in construction. Workers drove 1,300 steel pilings approximately 25 feet into bedrock for the foundation of the airship hangar known as the Akron Air Dock.
The girders, or the supports for the sidewalls, were fabricated on the ground. And then one side was put in place, and the second one was put in place, and then to hold the top portion in shape, there were temporary columns that were erected on each one. And then a locomotive crane would pick up that top section, hoist it up into position, and then lower it down until the side girders and the top were in place.
Similar to a Roman arch, the air dock's strength came from its shape. Once the middle or keystone section was put into place, the arch was complete. This evenly transferred the weight of the arch to each side, while pushing the sides together, which strengthened the entire structure. The new air dock would reflect lessons learned from Lakehurst. The most important of these was door design. Unlike the Lakehurst doors, which opened beyond the hangar, causing wind disturbances, the air dock used an innovative design, the clamshell, also known as orange peel doors. The doors were set on a railroad track and when opened would slide around the shell of the hangar. The air dock only took 12 months to complete. When finished, it measured 1,175 feet long, 325 feet wide, and 211 feet tall. In June 1929, in the new air dock, engineers started work on the first of 2 great airships, the 785-foot-long USS Akron. They completed it in September 1931. Immediately afterward, work started on the similarly sized USS Macon. The Macon stayed in Akron only long enough to be built. Its permanent home would be about 2,000 miles west of Akron in Northern California. The U.S. Navy considered 70 locations before building an air station, including an airship hangar, in Sunnyvale, a San Jose suburb.
There was no television in those days, so this took place of watching your favorite program on TV. Just go down there to Mountain View, Sunnyvale area, and watch Hangar 1 being built.
It took nearly $5 million to turn a hayfield into the West Coast's largest airship hangar. Moffett Field's Hangar 1 is more than 1,100 feet long, 211 feet tall, and 308 feet wide. It would be the last of the great steel and concrete airship hangars built in the United States. America may have been proud of its fleet of military airships, but in 1930s Europe, airships were engaged in commercial aviation. Since 1925, Germany had been allowed to build airships and hangars. This was possible because Zeppelin Company developer Hugo Eckener had convinced the Allies to ease the terms of the Treaty of Versailles. The Zeppelin Company had flown more than 2,000 intercontinental and continental passenger flights by 1937. But on May 6th, the beginning of the end of commercial airship aviation took place at Lakehurst, just beyond Hangar 1. On its 11th trip to America, the mammoth 803-foot-long Hindenburg airship burst into flames in front of film cameras as it attempted to land.
Get it started, get it started. It's crashing, and it's crashing terrible. Oh, my, get out of the way, please. It's running.
Several decades later, there is still debate on what caused the pride of the German airship fleet to become completely engulfed in flames in only 34 seconds.
20, oh, 400 or 500 feet in the...
But undaunted by that tragedy, Germany still went ahead with plans for a commercial airship center, Rhine-Main. The Zeppelin Company envisioned building 5 Frankfurt-based hangars. There would be 4 outlying hangars surrounding one in the middle that would rotate for takeoffs and landings of airships.
What made Rhine-Main so very unique is that for the first time, passengers could fly from, say, Holland, from England, from Spain, into the airport. They would stay overnight at a very ritzy hotel down in Frankfurt, and in the next morning it would be brought out to the airship station and board their airship for their, quote, intercontinental airship flight.
However, only 2 of these hangars were built before the Nazis started dismantling the airship program. The legendary Graf Zeppelin and Graf Zeppelin II, the sister ship of the Hindenburg, were taken apart and their aluminum skeletons used for airplane production. On May 5, 1940, both Frankfurt hangars, shining examples of German innovation and technology, were dynamited in an effort to ensure the safety of the Rhine-Main airport. The Nazis felt the massive hangars would be obvious targets for the Allies. As the U.S. entered World War II, it rethought its choice of materials used in hangar construction. Because of its permanence and structural strength, steel was favored by hangar engineers. But the use of steel was abandoned because it was needed for the war effort. So hangars were built of wood, including 2 more at Moffett Field. Both Europeans and Americans realized the need to still build large hangars that could fit a few airships or several blimps inside them simultaneously. These new wooden hangars would be critical to the success of America's war effort, because American blimps would play a significant role in World War II. 150 U.S. blimps and airships were in service. They were used primarily as anti-submarine scouts and in air-sea rescue. But they also provided invaluable security for the U.S. naval fleet.
Ultimately, United States Navy airships during the Second World War escorted 89,000 surface ships without a single ship lost to enemy action during the Second World War. 1 blimp is confirmed lost to enemy action. The operational reliability and record of the U.S. Navy airships was so successful, in fact, that even after the war, when there was a general cutback in all aspects of military operation, the airship program was kept alive.
Despite its military achievements, commercial airship use never took flight. However, commercial aircraft use was growing, creating a demand for a smaller, new kind of hangar, one that could still be used for military and commercial ventures. Next, monumental new homes for vehicles that would change the face of aviation. The Akron Air Dock is so large that sudden temperature changes cause clouds to form inside the hangar, producing light rainfall. Hangars will return on Modern Marvels. In 1966, the mission was clear: build the biggest jet ever. But Boeing engineers knew their existing facilities couldn't house a fleet of jets with a 220-foot wingspan. A new hangar would be necessary. The Everett, Washington home for the newly designed Boeing 747 would be massive. In the spring of 1966, workers started clearing away 780 acres of forest. Nearly 5 million cubic yards of earth were moved. That's enough to build a 10-foot high, 10-foot wide dike from New York City to Washington, D.C. 34,000 tons of structural steel were acquired for a building to house the airplanes that would change the airline industry. Not only was the jet larger than anything seen before, so too was its hangar. Simply put, it is the largest building by volume in the world. The hangar covers 98 acres of land and is 114 feet tall. Its front doors are 300 feet wide and 87 feet tall. The growing popularity of commercial air travel may have led to the enormous Boeing hangar. But even in its infancy, the aviation industry needed covered shelters to fix, tweak, and fine-tune the mode of transportation that would soon dominate long-distance travel. At the turn of the 20th century, two Ohio brothers, Orville and Wilbur Wright, fashioned the first airplane. But before their historic flight, they faced the same problem as other lighter-than-air trailblazers from a generation earlier. Where do you build and then house your vehicle?
That hangar was built at Dayton in about 1902, and it was just a simple wood frame building. Basically, this big garage had to house this machine, just as, you know, a garage would house a car or a carriage or a buggy of some kind.
This very first airplane hangar was a fraction of the size of von Zeppelin's 425-foot hangar on Lake Constance. It was roughly 30 feet long and 48 feet wide, just big enough to protect the Wright brothers' 28-foot-long, 40-foot-wide plane. The Wright brothers' success jump-started airplane production, which of course increased the number of airports and hangars. These early hangars were nothing more than workshops. They were often just a series of rectangular garages attached to each other and considerably smaller than their airship siblings. These early hangars didn't change much until the 1930s.
When we think of airports and aircraft factories and maintenance facilities and hangars, we think of very utilitarian buildings, steel and glass sheds, basically. But what's interesting in the 30s is that you have a very conscious attempt to hide the function, if you will, under an elaborate decorative skin.
For the first time, airplane hangars emerged from the shadow of their airship brethren. These new homes to a rising industry would be elegant structures, not just utilitarian sheds. Leading the charge were Le Bourget in Paris and New York City's LaGuardia, both built as their cities hosted world fairs.
These buildings are very stylistic, very streamlined, almost classical in some ways with their decorations, buildings that celebrated flight in a very public way.
However, just a few years later, the market for beautiful airplane hangars would diminish. World War II forced designers to build nondescript utilitarian hangars with just a hint of elegance. For the first time, arched roofs were used in airplane hangar design. This extra room allowed hangars to house military blimps during the war. One of the best examples is in Tustin, California. There, two World War II-era hangars built of prefabricated pressure-treated lumber were completed in an astounding 60 days. When finished, they were the largest clear-span wooden structures in the world. Almost 300 feet wide at the base, more than 1,000 feet long, and 171 feet high. Down the coast in San Diego, the North Island Naval Air Station hangars also had arched roofs. The hangars were constructed of thin-shell concrete with a span of 289 feet and a depth of 240 feet, making them the largest concrete airplane hangars in the U.S. to date. For the next 50 years, large airplane hangars dominated the industry. But the LaGuardia and Le Bourget Art Deco hangars of the 1930s would be remembered. These elegant hangars captured the attention of the German airliner Lufthansa. In 1994, they bridged the functional role of hangars in remarkable fashion.
This is a very elegant steel and glass building, essentially, where Lufthansa brings in these big jumbo jets and tears them down, strips them of the paint, and completely rebuilds them. What's nice about this is that you have this elegant steel and glass shed, but you also have a very expressive truss above to remind you of the origins of these big hangars.
The Lufthansa hangar is 500 feet wide and 90 feet tall. The entire fleet of jets is remodeled and serviced here. But the Lufthansa hangar is a rarity.
As an architect or as an architect-engineer team or something, you have to have a client. You just don't go out and build a hangar. Unless there is a need, I don't see a great many clients coming forward at this time, maybe in a few years.
The lack of new airplane hangars is a ringing endorsement for the works of yesterday's designers. They're simply built too well to replace. Next, America's burgeoning space program erects a structure large enough to house the mightiest rockets ever built. The Boeing Everett facility is so large that it could house 75 football fields. Hangars will return on modern marvels.
Achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
The space race was on, and the Soviets were in the lead with the successful launch of Sputnik 1, the world's first artificial satellite. But President Kennedy's 1961 congressional speech energized a nation. Since 1958, Cape Canaveral, Florida had been the launch site for America's early satellites. However, the existing facilities weren't large enough for the space vehicle that would take man to the moon. This creation would become the largest rocket ever built, the 363-foot-tall Saturn V, and that rocket would need a hangar unlike any other.
And that's where the vehicle assembly building come in. The plans started coming out. We kept looking at the plans, and we didn't believe the plans we were seeing.
The new Saturn V rockets would be built here on Merritt Island, about 3 miles from Cape Canaveral. From the start, engineers were concerned about the colossal building possibly sinking into Florida's native marshland. The solution was to drive 4,200 steel pipe pilings, each 16 inches in diameter, into the marshland to a depth of 160 feet. This would anchor the vehicle assembly building, or VAB, on a bedrock foundation. Now that the foundation was in place, workers began to assemble the building.
Most of the materials come in by rail at that time, and a lot of it was assembled just like a rector set when you put it in. Everything was numbered. This piece went to that piece, that went to that, and bolted in there. Hoisted it up, you had to have super big cranes there. Everybody was cutting, welding, bolting, and the things were going up all over the place there. There was about 3 different sections of the VAB being built at one time. There was a continuous upgrading of it as they were trying to design, because nothing had been built like it. So it was brand new, and all the engineers would go back and study things. Next thing they come back with another modification to it and add this to it or delete. And they had to watch the tonnage of the steel.
The sheer magnitude of the VAB set it apart from other NASA construction projects. It would require nearly 100,000 tons of steel and 65,000 cubic yards of concrete. When completed, it would be 716 feet long, 518 feet wide, but most impressively, it would be 525 feet high.
It's hard to relate to this building as being very elegant and being very significant that way in terms of design, but in scale, it's absolutely overwhelming. It was built to house 4 of Wernher von Braun's massive Saturn V rockets with Apollo capsules on top. So that means it's basically 4 buildings that are more than 34 stories high put together. In Chicago, I think the average skyscrapers are about 40 stories high. So think of 4 of these buildings put together. This is just incredible.
The VAB would cover 8 acres of land and could withstand winds of up to 125 miles an hour. Despite its massive size, it took only 11 months to finish construction of the facility that would house the world's largest rockets. In November 1967, the first Saturn V rocket was launched. Finally, on July 16, 1969 at 9:32 a.m., the flight that President Kennedy had predicted began. The launch site, named to honor the slain ex-president, was the Kennedy Space Center. Four days later, on July 20th, 1969, astronaut Neil Armstrong became the first man to walk on the moon. During the 1970s, space exploration reached new heights, as did activity in the VAB. In 1981, a new era in space exploration dawned. NASA scientists had developed a new reusable vehicle designed to transport people, spacecraft, and equipment to and from Earth orbit.
5, 4, we've gone for main engine start. We have main engine start.
The Space Shuttle, which consists of the orbiter, external fuel tank, and 2 solid rocket boosters, is about 184 feet long, 76 feet high, and 78 feet wide. Like the Saturn V, it would be assembled in the Vehicle Assembly Building. The VAB underwent a slight facelift to accommodate its new tenant.
They stack the space shuttle in there. They'll bring the orbiter in there, and then they bring the SRBs, the solid rocket boosters, and hook them up in there, and then the external tank, they hook it up. And then they stack it on top of the launch platform, and then the crawler comes in and picks up the launch platform with the orbiter on top and walks it out to the launch pad and sets it down on the launch pad.
The Vehicle Assembly Building continues to be the heart of the Kennedy Space Center more than 40 years after its groundbreaking. Next, another massive hangar rises at Cape Canaveral to house a new generation of rockets. The Vehicle Assembly Building's 456-foot doors are taller than both the Statue of Liberty and St. Peter's Basilica. Hangars will return on Modern Marvels. 3 decades after the Saturn V carried man to the moon, Boeing has developed the next generation of rockets. The Delta IV, a new rocket system that will unlock more mysteries of deep space.
It could actually put a school bus-sized payload into orbit around the Earth. Or we can launch satellites out past the planets.
And just as the Saturn rockets needed the Vehicle Assembly Building, the Delta IV family of rockets needed a state-of-the-art hangar. The SLC-37, which includes the Horizontal Integration Facility, is the most technologically advanced rocket processing and launch facility in the world. Here, Delta IV rockets are assembled horizontally instead of vertically. Because the rockets are closer to the worker's eye level, more final checks are conducted inside the hangar. This cuts down on the amount of time a rocket is on the launch pad undergoing more pre-launch tests, which significantly decreases the cost of rocket maintenance.
When we first started developing the Delta IV program, we were looking for operational items that could reduce the amount of time it was here at the launch site. And so one of the things we did was send some of our engineers over to Russia to see how they did it, because they process horizontally, and then the day before launch they would erect the vehicle and then shoot it off.
The centerpiece of the new Boeing rocket launch complex is the aptly named Horizontal Integration Facility, or HIF.
The Horizontal Integration Facility is unique in several ways. First of all, the bays are 250 feet long and 100 feet wide. That's in order to handle a heavy vehicle which has 3 common booster cores strapped together. And so you have to have a very wide hangar.
The 100,000 square foot, 7-story tall structure is so wide that 5 basketball courts can fit in one of its 2 bays. But the standalone, jaw-dropping technological marvel of this facility is its floor.
Because we're mating horizontally, the tolerances are very tight, and so we have to have a super flat floor. Now, what that means is, over that 250 feet by 100 feet, it can only vary 3/8 of an inch this way and also this way.
Our engineer stepped up to the plate and came up with a concept of 12-inch thick floor with absolutely no reinforcing steel. And by not having this reinforcing steel, we eliminated construction joints. So now, with no construction joints, we have a level floor. In fact, it's a world record. Engineering News Record magazine recognized that this was the world's levelest floor.
But the world's flattest floor wouldn't stay that way long if the building surrounding it was unstable. Designers encountered the problems faced by engineers charged with erecting the vehicle assembly building almost 40 years earlier in the same Florida marshland. However, instead of sinking hundreds of steel pilings into the marshland, Boeing's need for a super flat floor required engineers to build 6 concrete footings, each 22 feet wide, 7 feet deep, and 260 feet long. These footings rest on a bed of compacted sand and concrete. The innovative use of the concrete footings proved a better solution than steel pilings, because the footings have more mass than pilings. That produces a more secure foundation.
Here on the Cape, we were faced with a lot of design challenges, and one of them being that the wind load is for a 140-mile-an-hour hurricane, and so the building had to be designed for that. And so the floors and the foundations are stronger just to hold the building down in those type of winds.
But dealing with the marshland and weather weren't the only obstacles engineers and workers faced while building this hangar.
We had animals to chase out of the project. We'd have to take a forklift and run wild hogs out of the project almost every morning. And one time, a 10-foot alligator came in through the front door, and one of our pipe fitters was crawling down in the tunnel and stepped on him. It was quite a surprise. He was quickly out of the tunnel, and we had to call Florida Wildlife to come and get the alligator out.
In the tradition of engineers of the great early hangars, the construction company of the HIF paid special attention to the hangar's doors. But unlike other solid hangar doors, these doors are made out of steel trusses covered with vinyl fabric. They are 76 feet wide and 44 feet tall. They can open or close in 55 seconds, and they can withstand 140-mile-per-hour winds. The HIF may be one of the newest great hangars, but now one of the greatest hangars of a past age, the Akron Air Dock, looks toward a new life.
We expect in the future to be building airships there again. We're part of an initiative now to look at high-altitude airships that will be close in size to the Akron and Macon, although built entirely differently from how they were built. So we're looking forward to continued long life for the air dock, and hopefully it'll once again be issuing large airships for the U.S. military in the not-too-distant future.
The great hangars have all been critical in the development of aviation. These enormous cathedrals are the silent partners in an ever-evolving venture, extending man's reach into the skies and outer space.